linear structure. Anyway, if we stretch it, we will have a linear structure. So this disk is addressable by sectors. We know. Last day we talked about given a circular disk, we have tracks, and then in every track, so the whole disk is divided into several tracks, and whole track is again divided into several sectors. And that sector is basically the smallest unit, which is addressed or which is addressable. So we can assume that okay, there is a sector, there is one another sector, there is another sector, there is another sector. So starting from say 0 to some maximum number of sectors, some maximum value. Say if we have just in this disk, say if we have only say 1 MB of disk or 1 KB of say one not 1 KB, in fact it will be 1023 multiplied by 2 to the power 9. So it will be 1 KB, 512 KB disks. I hope how I'm coming to 512 KB is clear to everyone. Hmm? How I have come to this number? So there are sectors starting from 0 to 1023. Let me just add my other device so that I can listen you properly. Your voice is very low. Hello. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Your voice is also clear to me. So my question was, given a disk where we have 1024 such sectors, so what will be the size of the disk? Because each sector is basically of having 512 bytes. Sector is of 512 bytes. So there are 512 bytes in a sector. So if there are 512 bytes in a sector, then the total size of this disk, which we are referring, is 1024 into 512. So this is basically a KB. So that means we can say 512 KB. So this disk we are talking about is of say 512 KB only. And we know that disk addresses can be from 0 to this. So this disk addressing is called logical disk addressing. Logic disk addresses. So we have disks. That disk is divided into say 1024 different sectors. Each sector contains 512 bytes, and the addresses which we generate is for a sector. So because each read and write in a disk occurs in a block. So like if you recall in a computer, when we address some area of RAM, we normally refer an area of RAM by either byte or word, isn't it? We talk about byte addressable computer or word addressable computer. So we never address a bit. That I think is clear to everyone. Hmm?
Yes, sir.
Yes.
Yes, sir.
That, that's
Yes,
true.
sir. Yes, sir.
Everyone knows it. We have either
Yes.
byte addressable computer or word addressable. Normally the architecture what we are using, even the last semester, whatever we discussed in context of byte addressing. So we have a computer where we can generate addresses for a byte. So whenever we are generating an address, that address is for a byte, a complete byte. So if we have a data which is lesser than a byte, then we append basically prepend 0 with that to make it an 8 byte. Sorry, 8 bit, 1 byte. Similarly, when we are reading or writing through a disk, basically we read or write through a disk in a block. We never read or write a byte from a disk. So remember, the RAM addresses are generated in terms of bytes. So byte addressable, a computer is byte addressable, a computer may be byte addressable mostly. So addresses are in terms of 1 byte or 8 bit. But when we read or write something from a disk, normally we read or write 512 bytes together. Usually we can have larger sizes also. So we can define block size which can be higher than this, but never lesser than that. So 512 bytes. So one sector, because at least we read or write one sector at a time. Now this is, and last day we also talked about, okay, given this disk, we sometimes, although this disk, which I a very small one, but you consider you have a disk of 1 TB, then you partition that disk into 2 or 3 different components. You call it as C drive, D drive, E drive. Sometimes you have C drive and D drive, and you have unallocated partition, which is never shown to you in Windows operating system, but that space is there. When right now, when you install in Windows, 2-3 small partitions are created, what is called as recovery and so on. And normally they are unallocated, and sometimes even they are allocated, you do not see them. So those partitions, last week our discussion was about partitions, how to partition them. This week we are going to discuss about what is called as file system, because in each partition what we will have is a file system. I'm not very comfortable with this mouse. Let me just move on to the other system. So we talk about file system today. So we know that every partition. So if I say that this is one complete partition, so I have a disk which is having this partition only. So this is the partition of complete partition, one partition in this disk only, like in a pen drive. And in this partition, we talk about several types of file system. Now today's discussion, or today's point of discussion, is a file system. What is a file system? Why is it needed? What are different types of file system? And what are the users of the file system? Okay, so can someone explain what is a file system? Anyone?
Sir, file system is how to organize data in disk, how to access and edit
Okay.
it from the disk.
Can you repeat? Your voice was really breaking down, so I could
Sir,
not hear.
file system is actually reading and writing from a disk and saving data to a disk. How
Okay.
to read write some data into disk, and how to save them, how to modify, delete, and that thing.
Okay. 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 Anyone else wants to add something to this?
Sir, file system can be said as a data structure, how our operating system will store and retrieve the files when it needed.
Okay. So that's good.
Yes, sir. We can simply say, sir, file system is a logical connection of files. Yes, sir. On a disk.
So that's what all of you. So thank you to all of you. Exactly what all of you told. If I just summarize them. So file system is basically structural and user data. Basically, the file system is a structure which confirms or which gives a way how the user data will be organized into that hard disk, isn't it? That's what everyone told in a different languages. That's all. So we are going to store our user data, and we need how to store. Like consider an office or even in your home, and you want to store your books. So in order to store books, you make certain idea. Okay, in this Almira, I will keep all my books, and while keeping all my books, I will keep, say, if I have several types of books, so I will keep my, say, starting from computer science as forensic books there, then the cryptography book here and so on. And then I will have the next track, I will have files, and then I will have some other documents and so on. So you define a way. That way is basically what a file system is. You consider a bigger office where you need to record or you need to store, say, basically the patient record. Consider a hospital or somewhere of that sort of thing. So you want to store the records of the patient. Now, how you will record? You know that thousands of so we have to find out a way how we can organize so that later on when they are coming, we can easily retrieve their data. That's what a file system is. If the file system is good enough, you come to say, if you have studied like library, a very concrete example, if I have to say, a best example can be a library. So in library, how books are arranged. So even if a new librarian joins, and if you study library science and if you go to a new library, you know exactly how books are organized. So you have read that theory, you have the idea, and you can easily move on to a new place. And you know, since the basic principle is known to you, you can immediately start participating and you can immediately start finding and storing the books. And that's what everyone has seen. But consider you are going to an organization, you have studied library science, and then you are going to an organization where the structure is not followed, where the earlier person who was keeping track of those records or who was maintaining this record has not maintained any library science strategies. They have just scattered the books in any almirah, they have just placed the books. In that case, if you want to find out that book, that will be very difficult for you. So basically all those knowledge of library science will be useless there. Probably you can think of, okay, sir, I will now start maintaining everything in proper way, but that will take a huge amount of time. And immediately you will not be able to, without starting, you will not be able to access that. So that's what a file system does. In case of file system, we talk about, because we are having different types of file system, there are so many file systems existing. At least, you know, everyone knows 5 to 10 names, very common names like FAT. In fact, in FAT, we have FAT, then FAT30, FAT16, then FAT32, then NTFS, and then we have EXT, so EXT2, EXT3, EXT4, then HFS, which is for Mac, and then APFS, now what Mac does, and then this Google Drives, etc. They have HDFS and so on, so they have their own format. Even Microsoft servers have their own format, REST, FT, and so on. So there are different names or different ways people have devised, but the basic principle remains same. Okay, so there are different categories of file system. There are different ways people have stored or people have devised different ways to store file systems, but the basic principle remains same. So what are those basic principles and what are those things? That's what first we'll look at. The first thing is file system category. And one more thing here, someone can write it as in this way, file space system. Someone can write in this way, file system together as a single word. Both are correct. Okay. First thing we need to describe, or we are finding out, or we are marking, or we are defining a file system is, or we are the general characteristic of a file system is, what is the category of the file system? So category of the file system basically takes care of the type of the data structure. So category defines the data structure by which the files will be stored or how the files will be stored. The unit size. Okay, I will come to that, what we mean by unit size. Exactly what is the size of each and every block. I just told that normally in a logical hard drive, we have a sector and sector is addressable. So we can normally say that a sector consists of say 5 bytes. So usually in some system, the unit size in a file system also can be 512 byte. Sometimes it can be bigger than that also. Sometimes it can be say 1024. Sometimes it can be even bigger than that. Okay, so you can say, okay, 10 sectors are, say 8 sectors together will constitute one block for my file. Okay, I hope that idea is clear what we mean by file system category, or how we are categorizing. What is the category word in a file system represent? So it contains the general file system information, basically the data structure which this particular file system is following, and then what is the unit size this file is using, and so on. So this is the first component in a file system. The second component is the content. Now, content is, as you can understand, what most of you were telling, that we want to store our data. So content comprises the actual data which is to be stored in a file. And that's why actually the file system has been developed. Okay, so mostly again here we contain exactly what is that unit size. So what is that unit size? How many such units are allocated to a particular file, whether it is stored in a contiguous manner or in a fragmented way. And we will see shortly that it is not possible for us to maintain the whole file system in a contiguous way. I hope the meaning of contiguous and fragmented is clear. If not, I will shortly come to that point. The third one is metadata. Metadata tells us exactly what are the other information, okay, which this file is storing, like when this file was created, when was this file last accessed, when was this file last modified, who is the owner of this particular file, and so on. What is the permission of permission on this particular file for different types of user. So all these defines, or all these are basically associated with a file, and obviously this is being stored in a file system only, or basically a file system is the only way which gives a place where this information can be stored. Got it? Sometimes
Yes.
this metadata may not contain name, because we have a separate name field for in several file systems. So that's why in this book what they have done is, but in some cases the file name can also be a part of metadata, but in some other file system this file name will not be a part of metadata. And that's why the author of this book have thought of separating them together. So now you can assume that file name, by the name itself it is quite clear. So file name, vertical name normally, which is given to a file, and that is for the benefits of the user. So this is for the user interaction. So it's a name which is assigned to a file, which is for human interface, or which is going to interface the file with the human being. So human can easily understand, easily find out, easily recall that file by that particular name. But ultimately, this file will be stored with certain numbers. Like this, in this scenario, if you consider, this is very analogous to what we call it as, say, IP addresses and the domain name. All of you know about IP addresses and domain name?
Yes, sir.
Yes, sir.
Yes, sir.
Achla, are you there? Achla Kumari. Arpita Srivastav,
Yes, sir.
can you explain what is domain name and IP address and how they are interfaced? Although there is nothing not related with this forensic class, but in general.
Sir,
You know about domain name and IP address?
Yes, sir.
What is domain name and what is IP address?
Sir, IP address is a logical address of a device. Sir, it is given to each and every device for connecting to the internet, and domain name, sir. Sir, sir, I know but can't explain.
एक डोमेन नेम का एग्जांपल दे दो.
सर, सर जैसे कि आईपी एड्रेस से रिलेटेड सारे डिवाइस का एक डोमेन, मतलब कि एक डोमेन नेम होता है सर. जैसे
प्रिंस. ओके, थैंक यू अर्पिता. प्रिंस.
यस सर.
बोलो, व्हाट इज डोमेन नेम?
डोमेन नेम सर, जैसे सर google.com हो गया, gmail.com, ये सारे डोमेन्स हैं, और इनको सर जो हम लोग कनेक्ट करते हैं डीएनएस के थ्रू करते हैं, डोमेन नेम सर्वर के थ्रू, और जो वो डोमेन नेम सर्वर होता है वो हमारा आईपी से कनेक्टेड होता है, और आईपी जो हमारा होता है वो एक यूनिक आइडेंटिफाई, मतलब एक कह सकते हैं कि एक यूनिक एड्रेस होता है जिसको हम लोग.
So as thank you, Prince. So as Prince told, so domain name is what basically we human being remember. जैसे हम बोलते हैं google.com, gmail.com खोलना है, nitp.ac.in खोलना है, right? So say consider nitp.ac.in. Sitting in your home, if you hit nitp.ac.in, basically this nitp.ac.in is a domain name, but the lookup or page is not retrieved by the domain name. It is retrieved because the computer will be uniquely identified by an IP address. So इस domain name से हमारे यहाँ physical server है. Last time जब तुम लोग थे, हालांकि यहाँ पे नहीं था इसलिए मैंने यहाँ नहीं दिखाया, कंप्यूटर सेंटर में है वो एक सर्वर. So there is a physical server जिसके अंदर वो IP address दिया हुआ है. So that, but we human being normally cannot remember IP addresses of all these sites. So what we have done for that purpose, we have given a domain name that is easily memorizable to you, easily recognizable by us, isn't it? Now is it clear? Arpita?
Yes sir.
हम एक डोमेन नेम देते हैं ताकि हम याद कर पाए ह्यूमन बीइंग के, बट उसको एक्सेस कर. इनफैक्ट आईपी एड्रेस से भी आगे बढ़ोगी तो तुम ये होगी कि एक नेटवर्क इंटरफेस कार्ड होता है, वो एक अलग एड्रेस होता है, यूनिक होता है, तो कम्युनिकेशन उसके थ्रू होता है. हम उतने लेवल पे नहीं जा रहे हैं, हम यही बोल रहे हैं कि डोमेन नेम और आईपी. डोमेन नेम किसके लिए है? ह्यूमन बीइंग के लिए. आईपी किसके लिए है? कंप्यूटर्स के लिए, मशीन के लिए. सिमिलरली हम जब किसी फाइल का फाइल नेम देते हैं, दैट फाइल नेम इज फॉर ह्यूमन बीइंग. So we human being are giving a file name for our own purpose, but ultimately this file name will be stored as certain numbers only, and that number will be for a computer, right? So every file will be remembered by a number by the computer, but we give a file name to our say files so that we can remember them. Clear? Then the next one is application. Application defines in application field that basically application category contains say special features. So these data are not needed during reading or writing a file, and in several cases these are not included in file system specification also. For example, this application may include say user quota statistics, how big this file is and how many of times you have accessed it or used it, and then where is the journals. We'll talk about that very soon. So whether in file system journal where how this particular information can be used, and so on. Who has modified all those things and so. So that depends on the application part. So a file system. So in this book, in fact, these are not all say everywhere in all file system, all fields may not be available, but for simplicity and making everything clear, the author of this book have say partitioned the whole file system or presented the whole file system information into 5 different categories: file system category, content, metadata, file name, and application. And the relationship between them, if you see, figures in this book are anyway missing, so it's very difficult for us. So which I have shared at that figure. So if you see, let me just draw that figure. So it's something like this. Okay, so now if we go, so this is basically the file name. This is file name. So here we give say file 1, file 2, and so on, whatever name you give, something dot text. Then we have this one, these two are basically the metadata field. Metadata, I think this figure is not there in the book which I have supplied to you. So here they can maintain time, when this was created, accessed, and so on, for different files. So for this file you have something, for this file you have something, and so on. Then you can, this is basically the content. So some file can be bigger. So say this file is kept into two different blocks or two sectors. Say file is smaller, so it is kept only in this one. So this is the application basically. Say here you have stored quota. Okay, what is the quota of that user? And here you have this file system category. So here it represents layout and size information. Okay, so this is the first one, the category. Basically, this is category, which I had written. I had written 5 information. So category. Then this is basically the metadata. This is the content. So this part is the content. This is the file name, and this is the application part. So this is how the files are basically. You can view a file. So a file can have, a file system as a whole can have a category where you have the layout information, size information, and so on. Then you will have when the time the file was accessed, and then you have file names, and then what are the content. That means the actual content of the files, what is written inside that file. So sometimes it can be in one block, sometimes it can be 2 blocks and more than 2 blocks, and so on. And then the quota information and other information which is stored in basically that part. Okay, so now the question is exactly why we have divided into different components and what we can get from them. Okay. So the category information, as I told, the category information is it contains the general data that identifies how this file system is unique and where other important data are located. So this one, the category tells us exactly what is unique in this file system. That means how FAT32 is different from NTFS and EXT and so on. Because what type of data structures are used here, why different, how different informations are organized, and where other important data are stored. So this also has a layout of key where different in which block of this Almira, in which part of the Almira the different informations are stored. So the most of the data are stored in standard data structures in the first sectors of the file system and having a similar map basically. Then how to analyze, or what analysis we can do, or why we are important in this one. So as I told that this is basically the data structure, so where we are storing how the files will be stored. So what informations we can mine from them, or when we are doing the forensic analysis, then what sort of informations we can extract or we can do from them. So one thing you can do, say if you have a disk of, as I told that I had a disk of 512 kilobytes. Say for example. So I had a disk of 512 kilobyte which I had just drawn at the start of this class. And then I created a file system. And when this file system was created, this file system only used, say, 400 kilobytes. Due to uniqueness of this file system or due to the data structure which this file system is using, say it uses 512 blocks for the storing the real content, but it uses small chunks for the file name, say where the file name is restricted, and then the timing information and quota for all other field. It has a smaller part, and hence the total fragmentations or the total usage of this disk in this case is only 400 KB. Am I clear? This can happen. ये हो सकता है, एग्री करते हो तुम लोग?
यस सर, यस।
कैसे बताओ?
सर अगर टोटल साइज 512 है तो हम जब फाइल नेम वगैरह स्टोर करेंगे वो भी कुछ स्पेस लेगा ही। तो बाकी जैसे फाइल इस केस में अगर आपने 412 के भी ले रखा है और डेटा के लिए, तो अगर माइनस करेंगे 512 के से तो 112 के भी रहेगा। वो सब मेटा डेटा वगैरह जो भी आपने बताया वो सब में चले जाएगा।
Right. So what Abhishek is trying to say the block information हम लोग जो कंटेंट रखेंगे वो 512 का ही रखेंगे। से फॉर एग्जांपल एग्रीड कि 512 कंटेंट रखेंगे, प्लस हम मान लो कि 80 बाइट्स रख के उसमें फाइल इंफॉर्मेशन दे सकता है। तो एक फाइल के लिए टोटल या और सब मिला के हम तो एक फाइल के लिए टोटल कितना जगह दे रहे हैं? 600 का 6 बाइट ऑलमोस्ट। और इस तरह से अगर ये थोड़ा और मैनिपुलेशन करोगे तो देख सकते हो कि इस तरह का कुछ फिगर आ सकता है। दैट मींस 512 पूरी तरह से यूज हो जाए, ऐसा नहीं हो सकता है। हो सकता है कि कुछ चीजें कुछ जगह रह जाए। राइट, दैट्स व्हाट अभिषेक वाज आल्सो ट्राइंग टू से। हम कंटेंट 512 साइज के ब्लॉक में ही रखे हैं, लेकिन अदर इंफॉर्मेशन भी स्टोर करने हैं। और इसको हम मान लो फिक्स साइज का कर दिए कि फाइल नेम जो है बहुत सारे, जैसे ओएस में जानते हो कि पहले फाइल नेम 32 बिट से बड़ा नहीं हो सकता था या 32 स्ट्रिंग से ज्यादा नहीं हो सकता था। इट द स्ट्रिंग साइज कैन बी 32 ओनली, लाइक सी प्रोग्राम्स, अर्लियर प्रोग्राम्स इट वाज अ रेस्ट्रिक्शन। तो उस तरह का अगर हम रख देते कि हाँ 32 साइज का ही होगा, ये कोटा से इतने साइज का होगा, ये इतने ही हम रखते हैं। जैसे यूनिक्स में पहले बहुत सारे टाइम इंफॉर्मेशन नहीं रखते, क्रिएशन टाइम रखते थे। आज के दिन में भी एसएसडी डिस्क जो यूज करते हैं ना जब, तो एसएसडी डिस्क का एक प्रॉब्लम है कि एसएसडी डिस्क में कितनी बार रीड राइट हो सकता है। जैसे नॉर्मल जो हार्ड डिस्क है, जो मैकेनिकल हार्ड डिस्क है एज सच, सो मैकेनिकल हार्ड डिस्क में वो प्रॉब्लम नहीं है, तुम उसको जितनी बार हो वाइप आउट करो और फिर से लिखो। बट इन एसएसडी डिस्क देयर इज अ लिमिट, तुम कितनी बार एक चीज को ओवरराइट करो उस एसएसडी डिस्क पे ओवरराइट कर रहे हो। इसलिए मोस्ट ऑफ द टाइम क्या होता है कि जब लोग एसएसडी डिस्क यूज करते हैं तो दे डिसेबल द एक्सेस टाइम, एक्सेस टाइम को डिसेबल कर देते हैं बहुत बार, क्योंकि एक्सेस टाइम एक ऐसा टाइम है जो फ्रीक्वेंटली अपडेट हो रहा है। जब भी तुम फाइल को खोल रहे हो, दैट एक्सेस टाइम विल बी चेंज्ड एंड दैट रीड राइट, बेसिकली दैट राइटिंग will reduce the lifetime of SSD disk. So इस तरह का हम कुछ रेस्ट्रिक्ट कर सकते हैं कि इतना ही टाइम दे। तो इस तरह से करके पता चला कि हम 400 KB का एक फाइल का इंफॉर्मेशन 400 KB का रख सकते हैं। तो ये अगर करोगे तो कभी भी 512 पूरा यूज नहीं होगा, कुछ फिट्स बाकी रह जाएंगे। से मान लो कि 112 KB का साइज बाकी रह गया डिस्क में। सो हम लोग ये हमारा जो पूरा डिस्क था ऐसे we started कि ये हमारा सेक्टर साइज था, ठीक है, ये सेक्टर था से 0 से लेके 1023। तो अब क्या करेंगे, मान लो कि हमने पहला सेक्टर छोड़ दिया ऐसे ही कि पहले सेक्टर में तो हम सिर्फ फंक्शन रखेंगे लेआउट का और बाकी चीजों का। दूसरे सेक्टर में हमने क्या किया, क्योंकि आई स्टोर द फाइल इंफॉर्मेशन की कहाँ कौन सा फाइल है, से फाइल 1 का एक इंफॉर्मेशन कुछ रखे एंड देन कि ये सेक्टर 2 में जाएगा, सेक्टर 3 में जाएगा। हमने इस तरह से सेक्टर यूज करना शुरू किया कि पहले रियल यूजेस करेंगे फाइल का इस तरह से, और जो रियल कंटेंट के लिए यूज होगा वो कंटेंट के लिए यही सारे फील्ड यूज होंगे, सिर्फ इतना ही यूज होगा कंटेंट के लिए। फिर लास्ट को भी छोड़ दिए। Am I clear? कि ये पार्ट तो ऐसे ही लेआउट इंफॉर्मेशन पार्टीशन इंफॉर्मेशन में जाता है। इस पार्ट में हम लोगों ने सारे फाइल्स के जो भी अदर मेटा डेटा है वो वहां से रख लिए कि यहाँ से पॉइंटर क्रिएट करेंगे कि पहला फाइल से फाइल नंबर 1 इस जगह पर स्टोर्ड है, 2 so this is stored at third this location, file number 3 this will be, and उसका जो भी मेटा डेटा है वो यहाँ स्टोर होगा। तो 2 फील्ड तो ऐसे ही चला गया और लास्ट वाले को भी संभव वो छोड़ दिया, नहीं यूज कर पाया किसी भी कारण से। सो दिस स्पेस जो यूज नहीं हुआ, दिस इज कॉल्ड एज स्लैक। लास्ट डे ऑल्सो हम लोग डिस्कस किए थे इसको, ये स्लैक है। सो अब अगर तुम देखो तो हमारे पास कितने एड्रेस हैं। एक्चुअली एक एड्रेस था जो सॉरी फिजिकल एड्रेस था, पहले बार मैंने गलत लिख दिया था। पहला जो हमने एड्रेस लिखा था वो फिजिकल सेक्टर एड्रेस था, फिजिकल सेक्टर एड्रेस। सो एक तो फिजिकल सेक्टर एड्रेस होगा जो कि रियली में ये होगा। सो स्टार्टिंग फ्रॉम सेक्टर 0 सेक्टर 1023। उसके बाद क्या हो सकता है कि जब फाइल सिस्टम देखेगा या फाइल सिस्टम के तौर पे देखेंगे तो हम लोगों को एक लॉजिकल एड्रेस मिलेगा, और ये लॉजिकल एड्रेस अगर देखो तो ये पूरे फाइल सिस्टम और पूरे डिस्क को नहीं यूज किया है, क्योंकि ये लॉजिकल एड्रेस स्टार्ट है 2 से और ये खत्म हो जा रहा है 1022 पे ओनली, राइट। लेकिन जब इसको एड्रेस करेंगे तो रियली में ये क्या होगा, ये इसका नंबरिंग भी हम 0 से स्टार्ट करेंगे। दिस इज सेक्टर नंबर और लॉजिकल एड्रेस नंबर 0 1 2 3। हम हमेशा नॉर्मली 0 से ही स्टार्ट करते हैं हम लोग किसी भी चीज का काम, बट दिस 0 इज बेसिकली 2 इन द फिजिकल सेक्टर। इज इट ओके? सो ये चीज जाएगा कैटेगरी इंफॉर्मेशन में कि एक्चुअली कहां से स्टार्ट हुआ, ये लॉजिकल एड्रेस जो फाइल का रियल कंटेंट स्टोर होने वाला है वो कहां से स्टार्ट हुआ। सो देयर इज समथिंग व्हिच विल गो इन लेआउट इंफॉर्मेशन। इसलिए पहला जो पार्ट था ना लेआउट, तो देखो ये एक लेआउट बता रहा है ना, ओके, इज इट ओके? सो एक एनालिसिस अगर हम यहाँ से करना चाहें कि हम लोग यहाँ से क्या फॉरेंसिक एनालिसिस कर सकते हैं, तो इन दिस कैटेगरी फील्ड वी विल बी इंटरेस्टेड इन दिस फाइंडिंग आउट दिस स्लैक स्पेस कि क्या कोई स्लैक है क्या इसमें, क्योंकि स्लैक जब भी होगा तो दैट विल रेज आवर से आईब्रोज की शायद वहां पे कुछ जो है जगह खाली पड़ा है, एंड दैट स्पेस कैन बी यूज्ड फॉर हाइडिंग द इंफॉर्मेशन बाय द यूजर। Am I clear? Is it okay?
सर
हाँ बोलो।
सर हमारा जो लेआउट वाला जो सेक्शन है वो हमें ये बताएगा कि फाइल का कंटेंट कहाँ से शुरू हुआ है, ये इसमें थोड़ा डाउट था मेरे को। अच्छा ठीक है सर मतलब अगर हमें फाइल का अगर एक पर्टिकुलर एक्सेस करना चाहेंगे तो उसका एड्रेस वो हमें बताएगा।
जैसे फाइल सिस्टम में ये कंपोनेंट्स होंगे ना, जैसे अभी हम लोग क्या डिस्कस किए कि फाइल है, एक फाइल सिस्टम है, तो फाइल सिस्टम क्या क्या इंफॉर्मेशन स्टोर कर रहा है कि वो लेआउट कैसा है, उसका साइजेज क्या है, फाइल नेम्स कितने बड़े हैं, किस साइज के हैं, किस तरह से लिख सकते हैं, उसका अदर मेटा डेटा लाइक टाइम, कब एक्सेस हुआ, कब क्रिएट हुआ, कौन कौन एक्सेस हुआ, उसके रियल कंटेंट, so that's will require the maximum space। और ये ऑप्शनल है, सब में नहीं भी हो सकता है
जी सर,
ये भी ऑप्शनल है, मतलब ये भी कुछ में कुछ फील्ड हो सकते हैं, कुछ में और ज्यादा हो सकते हैं, कुछ में और भी ज्यादा हो सकते हैं, डिपेंडिंग ऑन द टाइप ऑफ द फाइल सिस्टम।
जी सर।
नेम तो होगा ही होगा, अगर नेम में भी रेस्ट्रिक्शन हो सकता है, कुछ फाइल सिस्टम में कहीं कहीं बड़े नेम देंगे, तो इस होल चीज को कैसे लिखा जाए। तो अब जब फाइल सिस्टम बेसिकली क्रिएट होता, तो पहला सेक्टर हम जानते हैं कि हम लोग लास्ट डे जो दिख चुके हैं ये चीज, कि ये जो पहला सेक्टर होता है वो किस लिए यूज करते हैं, वो हम लोग यूज कर लेते हैं पार्टीशन इंफॉर्मेशन को स्टोर करने के लिए, यही ना।
यस सर,
दैट वी हैव सीन एंड दैट विल बी देयर ऑलवेज, वो चेंज नहीं होने वाला है।
ठीक है सर।
पहला सेक्टर तो उसी चीज के लिए चला जाएगा कि हमारा इस डिस्क में, जिस डिस्क की हम बात कर रहे हैं, इस डिस्क में कितने पार्टीशन हैं और वो कहाँ कहाँ से शुरू हो रहे हैं।
जी सर।
और अगर एक्सटेंडेड हुआ तो बीच में भी इस तरह के फील्ड आएंगे और जहां से फिर एक्सटेंडेड शुरू होगा, दैट वी हैव डिस्कस्ड इन लास्ट वीक।
यस सर।
तो पहला अच्छा गया। उसके बाद आप फाइल सिस्टम की सारे इंफॉर्मेशन स्टोर करते हैं, तो ऑब्वियस है कि ये सारा इंफॉर्मेशन भी किसी जगह पे स्टोर होगा।
यस सर, यस सर।
तो अगर हम बोल दें कि फर्स्ट सेक्टर में हम लोग, दूसरे सेक्टर में हम ये स्टोर करें कि जो फाइल्स आएंगे, से फाइल नंबर 1, यहाँ पे हम स्पेस बना लें कि से फाइल नंबर 1 के लिए हम बनाइए कि फाइल नंबर 1 उसका अदर मेटा डेटा कब क्रिएट हुआ, कौन क्रिएट किया, कितना ये है और वो फिजिकली किस जगह पे है। तो इस तरह का अगर एक टेबल बना ले, से फाइल नेम, हमने एक फाइल नेम दिया, फाइल 1 कब क्रिएट हुआ, से इतना टाइम में, कौन क्रिएट किया, कितना टाइम एक्सेस हुआ और फिजिकल क्या है, रख सकते हैं ना एक टेबल बना के। दैट्स व्हाट बेसिकली फैट डज।
यस सर।
तो कहीं ना कहीं तो इसको भी रखना होगा, इस टेबल को भी।
जी सर।
तो हम एक सेक्टर यूज कर सकते हैं, 2 सेक्टर यूज करते हैं। एक्चुअली 1-2 सेक्टर में तो होगा नहीं, यू अंडरस्टैंड कि
यस सर।
वी रिक्वायर अ ह्यूज नंबर ऑफ सेक्टर्स फॉर दिस आल्सो।
जी सर।
कंसीडर क्योंकि जिस छोटा सा डिस्क है इसमें हम एक ही सेक्टर में रख रहे हैं क्योंकि इतना ही ज्यादा फाइल हो सकता है।
ठीक है सर।
तो अब क्या होगा कि फाइल 1 तो ये हुआ। अब ये फिजिकल जो लोकेशन है, ये जरूरी नहीं है कि एक ही फिजिकल लोकेशन में ये हो जाए। तो हो सकता है कि यहाँ पे ही ये इंफॉर्मेशन फिर से रिपीट हो कि फाइल 1 उसका दूसरा कंपोनेंट फिजिकली दूसरे जगह हो। कोई इसको ऐसे रख सकता है, कोई इसको क्या रख सकता था कि फिजिकल वाले को ही मान लो कि 4 या 5 बीट का बना देता कि अगर और ये लंबा होगा तो इस तरह से हमको ये इंफॉर्मेशन नहीं रिपीट करना। हम यही से बोल देंगे कि पहला पार्ट है, उसके बाद दूसरा पार्ट कहाँ है, उसके बाद तीसरा पार्ट कहाँ है, एंड सो ऑन।
यस सर।
सो दिस इज व्हाट दिस मेटा डेटा। इसलिए ये जो लेआउट वर्ड लिखा हुआ था ना कि इंफॉर्मेशन का मतलब क्या है कि हम ले इस फाइल के इंफॉर्मेशन को स्टोर करने के लिए।
ओके सर।
अबे क्लियर? और भी कुछ है?
नहीं सर, अब ठीक है सर, क्लियर हो गया सर।
हेलो सर।
बोलो
सर, again sir, Slack concept, there is some doubt.
बोलो
Sir, sir, in Slack concept, sir, how it is created and which part it is called as Slack?
So anything which is not utilized. So that
Some
means
allocated space is also called as Slack.
Please repeat.
Sir, I am telling like if there is some unallocated space, then
that is also a Slack.
Okay, sir, fine. Thank you, sir.
Slack what will be used very frequently because as a forensic analyst, you are very interested in Slack space.
Yes, sir.
Say, consider a copy, a notebook simply. In a notebook, say there are 100 and 200 pages.
Yes, sir.
And somehow what you did at the start itself, you created certain structure. And you told, okay, I will use say 15 pages for say computer science, 15 pages for maths, physics, and so on. And then you found that okay, last 4 or 5 pages are left because
Yes.
you have given equal space to everyone. And since 200 was not divisible by that number, so you have 4 or 5 pages left.
Okay, sir.
That's the Slack space.
Yes, sir.
Okay. The second thing you can have, you know, actually sir ये middle portion जो है वो torn out हो जाता है क्योंकि वहाँ एक ही clip रहता है. So I have found from my previous experience that this middle portion I will not write anything. कि अगर पूरा लिखते समय अगर वो निकल भी जाए तो I will be safe. So you have left in between that.
Okay, sir.
So you have not allocated that space to anyone else while creating the partition itself.
Yes, sir.
So that is also a Slack.
Okay, sir.
Okay. One more
Yes.
Slack will come when we will write this content. अभी हम लोग क्या डिस्कस कर रहे हैं कि एक कंटेंट लिखने के लिए हम 512 बाइट का ले रहे हैं. But can
Yes.
you guarantee that every file is going to be of 512 or multiple of 512? No.
No, sir.
But we are reserving space in terms of that only. Isn't it?
Okay. Yes, sir.
So say if I have a file which is of size 600 bytes, then what will occur? I will come to this content and then I would have explained, but just अभी reference आया है तो मैं बता दूं कि if you store a file of that nature, 600 bytes file है, so what you will do? 512 you will allocate to one sector.
Yes, sir.
Then you have to take one more sector because 80 bytes are left. Sorry, 88 bytes. 88 bytes are left, and that 88 byte has to be written in one sector only, because we know that disks are addressed only in terms of sectors. So we cannot take 88 bytes from any place. We have to borrow or we have to buy one sector or complete sector. So I will buy this complete sector and I use only 88 bytes of this. So remaining spaces are again slack. Am I clear about slack now?
Yeah, sir. Then the new content will be started from the another sector.
New content means new file.
Yeah, yes, sir. Some new file will be started from the new sector.
Obviously, new file will be started from a new sector. A new file cannot start from in between a sector. So say you are going to buy something, say of a particular size, and you know that in market, say if you have, if I can show you, say if I am buy a box, say which can store this, ठीक है? इस disk को रखने के लिए मैं एक box खरीदने जा रहा हूँ, और I know that all the boxes are available for this size disk only. But unfortunately or unfortunately, I have some disk which is say of this size, which is much smaller than this. You can see.
Yes, sir.
ठीक है? Almost इसका आधा है.
Yes, sir.
But I know that boxes are available only of this size.
Yes, sir.
So I will buy this size of 2 boxes.
Yes, sir.
And I will place one in another first one and this one in second one. Say now if I have I have another disk, then I buy something of some new box of this size, because this size box is only available. Whatever is the size of the disk, we cannot say in one box I will keep 2 disks. That's not for me, because then we cannot address them. मान लो कि फॉरेंसिक फाइल बनाएंगे और तब अगर हम लिखते हैं कि ये फाइल इसमें है, that we cannot do. Okay, am I clear now?
Yes, sir.
So next file will always start from a fresh sector. It will never start from the other existing sectors. Okay.
Okay, sir.
Can we move on now?
Yes, sir.
So in basically, if you try to analyze this, so you can use fstat command, fstat command. So fstat command will show you the content, basically the information. Next is discuss. So first one was category. Next, let us come to this content one. कंटेंट में क्या क्या हो सकता है, जो अभी हम लोग जिस पे डिस्कस कर रहे थे, इनफैक्ट जस्ट एलाबोरेशन ऑन दैट. सो कंटेंट स्ट्रेटजी. सो कंटेंट में पहला जो अभी हम लोग डिस्कस किए कि से इफ आई हैव whole disk, or basically the logical whole disk, say if I have these are the sizes and my file system has told okay I can store my content in this area. Okay, so this is the area which has been given by the file system where I can store my files. And say I have utilized, this is very similar to your operating system classes. If you recall your operating system classes, इस तरह का structure देखे होंगे RAM के context में. Now अभी वही चीज हम लोग disk के context में पढ़ रहे हैं. That's only.
नहीं दिख रहा है व्हाइट बोर्ड वाला.
कौन व्हाइट बोर्ड ऑन किया है भाई? मैंने तो नहीं किया है.
सर सर आपका कैमरा ओनली दिख रहा है।
सिर्फ कैमरा वाला दिख रहा है सर, ऐसे
Okay, now is it okay?
नो सर।
किसी और ने व्हाइट बोर्ड ऑन किया हुआ है? Anyway, देखो तो अभी. Now is it okay?
यस सर, यस सर,
Okay.
इट्स फाइन।
So say if this is the place which had been just now we discussed. Okay, this is the place which had been given by the file system where we can store our content, the real content of the file. Okay, so now if it is the real content of the file, say पहले से यहाँ पे एक file store है, say this is file 1, this is file 2, this is file 3.
So the book is showing here.
सर व्हाइट बोर्ड नहीं दिख रहा है सर।
यार ये प्रॉब्लम है। Is it okay?
Yes sir, yes sir.
यस सर।
So say we have this is the field हम लोग यहाँ डिस्कस किए ना कि यहाँ से यहाँ तक जैसे मान लो कि we can store our content from this place to this place. So I'm just elaborating that area. कि this is the area where we can write our content. Good. And somehow we have created already kept 3 files in our system. हमारे डेस्क पे 3 फाइल पहले से हैं, file 1, file 2 and file 3. These 3 files are there and they are at these places. So these are the addresses where they are placed. So these sectors are already occupied. Remaining sectors are free. Now I have to store a new file named file 4. And when this requirement of file 4 came, file 4 is of size say 1000 bytes. So 1000 byte means it will require 2 sectors. That's for sure. Isn't it? एक sector में तो नहीं होगा because one sector is of 512 bytes only we are considering here. So we require 2 sectors. So if we require 2 sectors, so what are the allocation strategies? हम कैसे इसको allocate कर सकते हैं? Call it as allocation strategy. If you recall your operating system classes, क्या करते थे? First fit, याद है? First fit, next fit, worst fit and best fit.
Best fit, yes sir.
यस सर, यस सर।
So we call it as first available. We do not call it as fit, we call it as first available. क्योंकि फिट तो होगा नहीं, साइज तो जो है वो फिक्स है। रैम में चूंकि फिट इसलिए बोलते थे कि रैम में हम लोग पार्टीशन कर सकते थे, छोटा कर सकते थे, छोटा बड़ा कर सकते थे in several structures. Here we say first available. So when file 4 is requiring space, so we can start from the first, so 0th sector, and we can say whether 2 sectors are available consecutive here. No. Next, no. Next, where it is available. So we can say here we can store file 4. Okay. We'll start from the start. So first available means I will start from the start. So that's what first available says. Good. Then the next is so next एक figure है यहाँ पे. Say we have a structure like this. So shaded area is allocated and white area is unallocated. And then last allocated was this. So दूसरा strategy हो सकता था कि if I have a requirement of storing this file, I could have started from this place only instead of starting from the first place. Last pointer मेरा जहाँ है उसके बाद से हम शुरू करेंगे. ऐसा क्यों करेंगे? So the problem with the first fit is or first available is if you say by this time when we delete a file normally this file is allocated. Now when some file is deleted, this area this file 1 is deleted. Then what first available will do? अगर ये इसको सर्च करने से पहले फाइल 1 डिलीट हो जाता तो शायद ये एरिया 4 को दे दिया जाता ना.
Yes sir.
ये एरिया 4 को मिल जाता क्योंकि वो शुरू से सर्च करता है, शुरू में ही उसको 2 ब्लॉक मिल जाते हैं. So this area would have been given. So the problem is if we use first available, every time we delete a file, there is a chance that if the file was at the starting sector, so if it was very close to that 0 sector or उसे order में अगर होगा, तो that file with that area will become overwritten. उस पे क्योंकि अब नया फाइल जब भी लिखेंगे तो वो डेटा ओवररिटन हो जाएगा, ओवरराइट हो जाएगा ना, बेसिकली हम उसको रिट्रीव नहीं कर सकते हैं, राइट. सो अगर समहाउ अगर एक तुम्हारे कंप्यूटर, तुमको एक कंप्यूटर मिला और जो कंप्यूटर फर्स्ट अवेलेबल स्ट्रेटेजी यूज करता है फाइल एलोकेशन के लिए, फाइल के कंटेंट एलोकेशन के लिए, सो मोस्टली क्या होगा, द प्रॉब्लम विल बी कि we will be unable to retrieve the first portions or the initial portions of from the initial portion of data. वहां से जो भी डिलीटेड है वो मैक्सिमम चांस है कि वो सब ओवररिटन हो चुके हैं. बट लास्ट पार्ट में हम लोग लेटर पार्ट इन द हायर हायर एड्रेसेस ऑफ दिस सेक्टर्स, हायर सेक्टर एड्रेसेस, we will have higher chance of getting the data. लेकिन पूरी तरह से कभी भी रिट्रीव नहीं होगा, क्योंकि मैक्सिमम फाइल के शुरू वाला पोर्शन अगर रिट्रीव नहीं हो तो सिर्फ बाद वाला पोर्शन रिट्रीव करके बहुत मीनिंगफुल इंफॉर्मेशन नहीं मिलेगा. Am I clear?
Yes sir.
Yes sir.
So the next strategy, so forensically ये बहुत वीक स्ट्रेटेजी है. अगर कोई कंप्यूटर इसको यूज करता है, कोई अगर हार्ड डिस्क मैन्युफैक्चरर या फाइल सिस्टम, इसको नॉट हार्ड डिस्क, बेसिकली दिस इज अ फाइल सिस्टम जॉब. सो अगर कोई फाइल सिस्टम इस तरह से डेवलप्ड है कि वो फर्स्ट अवेलेबल स्ट्रेटेजी यूज करता है, तो उसमें फॉरेंसिकली हम रिट्रीव करने के चांसेस बहुत हद तक खो देते हैं. नेक्स्ट स्ट्रेटेजी कैन बी कि हम लोग जहां लास्ट एलोकेट किए थे उसके बाद सर्च करें. लाइक इन दिस केस अगर नया फाइल का रिक्वायरमेंट आता है, नया स्पेस का रिक्वायरमेंट आता है, तो इंस्टेड ऑफ starting from this place, we can start from this place because this is the last space where we have allocated, so we can start searching from this area, and since we'll get here, we'll allocate here. So the benefit here will be it will be uniformly, so the overwriting will be done uniformly. नहीं.
Yes sir.
सो यूनिफॉर्म राइटिंग होगा, ये मोर बैलेंस्ड डेटा रिकवरी होने के चांसेस है यहाँ पे, क्योंकि यहाँ जो ओवर राइटिंग होगा वो हर एरिया में ओवर राइटिंग होने के चांसेस मोर और लेस सेम यूनिफॉर्म है. दैट्स अ बेटर स्ट्रेटेजी इन दैट. नेक्स्ट थिंग इज द बेस्ट फिट. बेस्ट फिट मीन्स कि हम लोगों को जब तक उसके समान, उससे एकदम उसी के बराबर मिल जाए. अगर 2 यूनिट चाहिए तो हम लोग 3 यूनिट मिल रहा है, वी कैन स्किप फर्दर एंड वी कैन से कि if 2 units are available somewhere, we can store them to just make that the files are always say contiguous, they are never fragmented. So but that will take extra time to search in that one. And even with the best fit strategy, you can never say that the file is never going to be fragmented, because if the files increases in size, that means if it is a file where you are writing again and again, so आज के दिन में हम फाइल लिखे फिर दूसरे दिन तो फिर वो बढ़ेगा, then probably we may need some extra space. So these are the 3 strategies: first available, next available, and best available. Right? This is the strategy, how we can write files. Then, as I told at the last, okay, there are some files where we are constantly writing. That means the size of the file is increasing. So if the size of the file is increasing, no issue. If it is increasing, so then how the information is maintained. Now there are several strategies by the operating system. So कुछ operating system क्या करते हैं कि whatever file we have, they just open that file in RAM space, write something, and then rewrite that in the disk space. Am I clear? मैं क्या बोला? So you have something, you have read that data in your RAM space, you have made all the modification, and then you will overwrite into that same space with the same name. Whereas some other operating system, what they do, when you are going to modify a file, they create a copy of that one. And then they do all the modification, whatever modification you are doing, they are doing all the modification in the RAM space, and then they create a new file, basically, with the same name at a different location, and then delete the earlier file. Is the idea clear? Distinction between these two are clear?
Yes, sir.
Yes, sir.
So that's the different process goes on in different way. Okay. So if it is creating a new file, again you can think of key, it can be stored in a best phase, say best available, next available, or best fit available way. If it is overwriting into the same place, अगर उसके वहाँ पे space है, good. If it is no, there is no space, then it will search for just one extra space which is used, और फिर वो वहाँ पे जाके उसको लिखेगा. Okay, so then we can have some consistency check in the data unique say allocation order. So like you might have seen, when you basically in case of pen drives, you might have seen it very frequently that once you insert a pen drive, you immediately get a message that the pen drive is not, the file system is not consistent. Do you want to make a check?
Yes, sir.
मैसेज आता है ना, very
Yes, sir,
frequently
आता
हम लोग
है.
मैसेज देखते हैं. So वो क्या होता है? So let's see that. So say if we have a system, say a file system, something like this. So these are basically the allocated space. Now these are the vacant spaces not allocated till now, and these are the allocated spaces. Now in allocated spaces में देखो, two, there is no entry. यहाँ पे कोई metadata entry नहीं है इसका कि ये कब create किया, किसने create किया, and so on. Whereas if you see in this one, there are two metadata entry. And this is wrong. So this is what we basically they mean by consistency check. कि ये consistency है कि नहीं. हो सकता था कि यहाँ पे जो एक metadata entry है, this one should have been for 2, but wrongly it has been mentioned or associated with 8 somehow. So this sort of checking is normally the check, and nowadays, in fact, every disk or every operating system is capable of doing this. Then next is the wiping technique, how we should wipe the data. So we have already done a lot of discussion, and you have done the experiment also how to wipe data. देख चुके हो ना?
Yes, sir.
इसको देख चुके हो DD command से how to wipe data.
Yes,
Normally
sir.
when you delete or when you make a quick say format, so in quick format what you are basically doing, you are just removing all those file system related information, and you are creating one new file system information, that's all. But you are never wiping out the data, whatever was data, whatever it was data to the particular disk, whatever was written, it will remain it is. But nowadays some formatting system and some operating system have wiping techniques also, like in NTFS. If you format a disk in NTFS format and do not use quick format, so you use a normal formatting scheme instead of quick format. अगर quick format वाला option disable कर दो, सिर्फ normal formatting करो, तो then they wipe out the data along with creating a file system. They make everything zero. Okay. So we have seen the Slack space metadata file recovery, encrypted file. So if you see name analysis technique. So let us stop today here. Tomorrow we'll start with the fat file system, and for lab classes next week, talk about how to find out this fat file system, do analysis in fat file system and NTFS file system. Okay.
Okay, sir.
So that's what we will do.
Okay, sir.
तुम लोग का एग्जाम कब है? मिड टर्म एग्जाम
28 को है सर.
कब से शुरू हो रहा है एग्जाम?
From
28 को ही है.
नहीं, स्टार्ट 28 से ही शुरू हो रहा है. मेरा पेपर मान लो कि ये पेपर 28 को है, एग्जाम शुरू कब से हो रहा है?
सर 28 से फर्स्ट पेपर ही है हमारा ये.
अच्छा, 28 को फर्स्ट पेपर है. दैट मींस आफ्टर होली वी विल हैव वन मोर वीक.
Yes.
In physical mode.
Yes, sir.
हाँ?
Yes, sir.
ओके. चलो अच्छा रहेगा, तुम्हारे लिए भी थोड़ा सा ये मिल जाएगा.